Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today. For exam LTAM, let Y1 denote the present value of an n-year term continuous annuity of 1 per year issued to X years old. Let Y2 denote the present value of a whole life continuous annuity of 1 per year issued to X years old. Z1 denote the present value of a continuous n-year endowment insurance of 1 issued to X years old. Z2 denote the present value of a continuous whole life insurance of 1 issued to X years old. Part A. Write down an expression for Y1 in terms of the force of interest, delta, and Z1. 2. Write down an expression for Y2 in terms of delta and Z2. Part B. Part 1. Write down an integral expression for expected value of Z1, Z2 in terms of the probability density function, PDF, of future lifetime and interest rate functions. Hint, use separate integrals for the period up to time n and the period after time n. 2. Show that the expected value of Z1, Z2 is equal to 2a bar x colon angle n minus v to the n times nex times 1 minus a bar x colon angle n. C. Use the expression from B2, using the expression from B2, derive an expression for the covariance of Y1, Y2. D. State with reasons whether covariance of Y1, Y2 would be positive, negative, or 0. And here's the solution. For part A, part 1, we have Y1 equals 1 minus Z1 over delta, with Y1 equal to A bar angle minimum of Tx and n, and Z1 equals to V to the minimum of Tx and n. For part 2, Y2 is equal to 1 minus Z2 over delta, where Y2 is equal to A bar angle Tx, and Z2 is equal to V to the Tx. Part B, part 1, Z1, Z2 is equal to V to the 2Tx for Tx less than n, and V to the Tx plus n for Tx greater than or equal to n. Therefore, the expected value of Z1, Z2 is equal to the integral from 0 to n of V to the 2t times Tpx times mu x plus 1. That's the PDF of the future lifetime. This expression Tpx times mu x plus t, the probability density function of the future lifetime, plus integral from n to plus infinity of v to the t times v to the n times Tpx times mu x plus t dt. And here is part 2. We note that E of Z1, Z2 is equal to the integral from 0 to n of v squared to the t times Tpx times mu x plus t dt, plus integral from n to plus infinity of v to the t times v to the n times Tpx times mu x plus t. That's the PDF of future lifespan dt, and that's the second moment of term insurance, so it's 2a bar x colon angle n with a 1 above the x. And this first integral is equal to that, plus second integral remains the same, integral from n to plus infinity, v to the t times v to the n times Tpx times mu x plus t dt. And then we do a substitution. T equals n plus s, then dt is equal to ds, and the values of s now start at 0. So this becomes 2a bar x colon angle and 1 plus integral from 0 to plus infinity of v to the n plus s times v to the n times n plus s px times mu x plus n plus s ds. And still 2a bar x colon angle and 1 plus, now we pull out v to the 2 nth times the integral from 0 to plus infinity of v to the s times npx times s p x plus n times mu x plus n plus s ds. Then still have that second moment. We put now v to the n times npx in front. That becomes the integral from 0 to plus infinity of v to the s times sp x plus n times mu x plus n plus s ds. That's equal to 2a bar x colon angle n 1 plus v to the n times nex times a bar x plus n. And now we add v to the n times nex to the first expression and then subtract it. So everything is unchanged, but now the combination of a term insurance and pure endowment with double the force of interest gives us 2a bar x colon angle n minus v to the n times nex plus v to the n times nex times a bar x plus n. So this is 2a bar x colon angle n minus v to the n times nex times 1 minus a bar x plus n. And then the covariance of y1, y2 is the covariance of 1 minus z1 over delta and 1 minus z2 over delta. So it's 1 over delta squared times the covariance of z1 and z2, which is 1 over delta squared times e of z1, z2 minus e of z1 times e of z2. And that's equal to 1 over delta squared times 2a bar x colon angle n minus v to the n times nex times 1 minus a bar x plus n minus a bar x colon angle n times a bar x. The covariance per d, the covariance is positive because if x lives longer, the value of the whole life annuity will be higher and the value of the term annuity will be larger as well. I perhaps should say larger here. Although in the case of this annuity, there is a maximum value it can reach because the annuity ends after n years. Please remember this is copyrighted material. The problem belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.